Hey, what's up everybody? This is the Helpful Hacker, and today we're going to be going over the networking core protocols room from TryHackMe. So we'll jump right in and get started with task number 1, introduction. So this is just going to give us an intro, tell us where we're at. We're currently in the 3rd room out of 4 rooms that are all about computer networking. It is recommended down here that you have done the networking concepts room before doing this room. You also just should follow the order and do the networking essentials room. It's helpful. I have full walkthroughs of both of those on my channel, so you can check those out there. And then in this room, we're going to learn about additional protocols, specifically these ones that are listed down here. So we'll dive into each one of those individually, and then you got to start your machine and start your attack box. So I already have my attack box open. I'm just putting that in a different tab so that it's easier for everybody to see. So yeah, read through all that, start your machines. Once you're done, you can mark complete, and with that, you're done with task 1. Now it's on to task 2, DNS, or remembering addresses. So basically, DNS stands for Domain Name System, and what it does is when you want to visit Google, you type in google.com. You don't have to go into your address bar and type in an IP address, right? But if you've done the other networking rooms, you should understand that things on the internet and in networking are uniquely identified using an IP address. So why is it that I can type in google.com and it knows where to take me? Because the computer needs an IP address. And the reason why you don't have to type in an IP address is because of DNS. And DNS automatically, it's quite an extensive process if you get into the nitty-gritty of it, but it goes through quite the process to determine what the IP address is for any given domain name. So that's why I can just type in a domain name, hit enter, and it'll automatically take me to the website. And so that's what DNS is for. It's super useful, or else we'd all have to be memorizing a bunch of numbers, which would be a pain, and it's a lot easier just to remember a domain name. And here they give you like example.com. So that's what DNS does. It works on layer 7, and it uses UDP port 53 by default and TCP port 53 as a fallback. And then within DNS, there's multiple types of records, and there's more than 4, but they're really only going to focus on these 4. And for the most part, these are the 4 that you're going to have to worry about. There's one other one that comes up sometimes, but especially in like TryHackMe, or if you're doing a box or something, or some sort of hacking challenge. But usually these 4 are the primary 4 that people are looking at to gather information. And so what these records are is there is the A record, which maps a host name to one or more IPv4 addresses. So this is the straightforward one. It's just example.com is actually this IP address. And so it's just a record for that, so that you can keep track of that. And then the quadruple A record, that is going to be for IPv6. So it does the exact same thing as the A record, but instead of using an IP version 4 address, it uses an IPv6 address, which is different. And I don't know that they've talked a lot about IPv6, but basically it's the newer version of IPv4, and someday it'll probably replace it, but as of right now, what we're mostly using is IPv4. So you don't have to worry too much about it just yet. And then the next record is called a CNAME record, and this record maps a domain to another domain. So example.com is the same as example.com, or it's the same as example.org, right? And all of those are going to the same domain, really. So that's what a CNAME record is. Then you have the MX record, and this is specific for mail. So if you have mail at that domain, who's responsible for handling the emails, right, for that given domain? So an example is at example.com, or like fill in the blank with, I don't know, whatever company you work for maybe. like test@example.com. That if you work for example.com, this might be your email address, right? So how is that set up? Where does it go? How does it work? Which mail server is in charge of it? And that's in the MX record. So if you want to look up any of these records and actually see them for yourself for any given domain, you can do that. And we do that using a tool called NSLookup. So you just type in NSLookup and then the domain that you're looking for, and it'll give you the name, it'll give you the address, and then it'll give you the name again, and then its IPv6 address. That's what that is. So this is kind of what the output looks like whenever you use NSLookup, just in the default mode. And then this is what the network traffic looks like when you do that. So this was captured using T-Shark after someone had done NSLookup. And then we can see here, so we are querying it. So this is the A record. And then we get our response with the A record, and then this is the quadruple A record, and we get our response, right? So pretty straightforward. We just send them something. We send them a query and we ask, it's on DNS. As you can see, that's the protocol we're using, and we're using port 86, which normally it's port 53 by default, but here that's what it has it at. And so we're using that, and we're just asking for the A record. So that's what the traffic looks like specifically for this NSLookup. And then we'll go down to some questions. So which DNS record type refers to IPv6? That would be the quadruple A. Which DNS record type refers to the email server? That's the MX record. So we have all these records, and DNS is awesome because we don't have to remember IP addresses. We can just remember domain names. So keep that in mind. And with that, we're done with task number 2. Now it's on to task number 3, whois. So whois is a command, and its output looks like this, and it gives you quite a bit of information, and you just type in whois, and then you give it a domain name. And so what's it for? Why does it work this way? So who is the person that gets to decide what those records are, right? So who's the authority that sets all of these records for any given domain? And the person that gets to do that is the person who registers a domain and pays for it, usually. Usually they pay, and then they're hosting a domain somewhere. And so whoever that is, they're in charge of these records. And because they had to register for that domain, there is information available out there about that. And so you can actually look at that information, right? So let's say I want to know who registered the domain Google, right? Who's in charge of that? Like, who bought it, who's paying for it, and how long have they had it? And so I could type in whois space Google, and it will give me all this information. Sometimes it'll give me the registrant phone number, the country, the city that they're in, the domain status. It'll tell me when it was created, when was the last time it was updated, all this good information about the domain registration. And so sometimes this works really well, and you can type in whois and you'll get a lot of good data about whoever registered. Other times there are actual companies, and they're not individuals. So a lot of times you'll get like a corporation, and then a lot of this will just be filled out with very generic like corporate info that's not all that useful. So it just kind of depends on the domain and how it was registered and what information's available, but you can always check with the whois command. So this is kind of what the output looks like. And now what we'll do is we will actually take a look at the questions, because I think that explains it the best. And we can check out first, what is the x.com, or when was the x.com record created? So we can come here, go to our terminal, Let me make this a bit bigger. And we can just type in whois and then x.com. And here we go. We can see domain name, registry domain ID, all this stuff. So in this case, see, so this is GoDaddy.com, which is, you know, a hosting company. So we get a bunch of their information here, but we can still see when this was actually created. It was created in 1993. So let's submit that, and that's the right answer. Now we can check out when was the Twitter.com record created. So that's a good one. So let's do whois Twitter.com. Oops. There we go. And we can see here, there's a bit more info. Twitter.com gives us the ID. Let's see. Registrar CSC Corporate Domains Inc. So again, it's a different company, but they do give you some information such as the registrant name, organization, and this, again, this is all company info. So it might not be exactly what you need, but if you do need company info, then you can usually find it there. And they even have admin information with different data. So yeah, so they wanted us to figure out when Twitter was created, or the date it was created. So we'll just copy that, paste it, submit, and with that we are done with task number 3, whois, which again, very useful. You'll use it all the time as you move through TryHackMe. So now it's on to task number 4, HTTPS, accessing the web. So HTTP stands for Hypertext Transfer Protocol, and basically what that means is just when you have a web page, it's built out of something called HTML, and it looks like this. So all of that is HTML, and the Hypertext Transfer Protocol is basically, we can send each other this stuff, and then our browser will read it and show us a web page. And that's pretty much in its most basic form what HTTP does and what it is. And so there's the regular version, which is just HTTP. Then there's HTTPS. The S stands for secure. So in HTTPS, all of this information is encrypted. So in this example, they're capturing this traffic with Wireshark, and we can read everything. If it was encrypted, we wouldn't be able to read it this way. Like, it would all just be gibberish. So that's the difference between HTTP and HTTPS. Some of the commands or methods that are used in HTTP and HTTPS are the get, post, put, and delete. You can read what all of them mean right here. The ones you'll see most often are get, which is where you're asking for data from a server, and then also post, where you submit data to a server. So an example would be we would get TryHackMe.com if we wanted to get on TryHackMe.com and do some rooms. We would post on TryHackMe.com if we wanted to make a comment about a room. And then the put command, what that'll do is that'll overwrite existing information, and then the delete command will just delete a specific resource on the server. So that's what those do. And then let's see, what else does it want us to do here? So here's an example. It gives us an IP. And so this is what we see when we type in this IP address. But what actually happened in the background was this. We sent this request. We said get in the / right there. That just means default page. That's all that means. So we're asking to get the default page of, and then there's the IP address. And then the server responds and gives us a 200, which means, okay, I got you. And then it sent us all of this, which is HTML. And then our browser took that HTML and read it and converted it to this, which is what it looks like. So that's the website, and that's how we got it. We can see that right there. We asked for it, it said okay, then it gave it to us. So you can read through all this, it'll tell you kind of what I just explained. But in addition, it lets us know that we can use Telnet to connect to the web server on port 80, and then we can do get, and again, that / just means the default page, right? And sometimes you have to put this host thing, other times you don't, depends on the web server. And in this case, they give us an example. What if we don't want the default page? What if we want file.html? Well, then instead of just doing the /, you do the / followed by the page that you want. So that's how you would get that. And then we have our question here: use telnet to access flag.html on this IP address. What is the hidden flag? Okay, so let me clear my terminal real quick. So we're going to do telnet, and then what is the IP address? Here we go. And then that's going to be on port 80. Okay, so now we're in. So now we got to do a get request. And that request is going to be for, what do they want us to get? They want us to get the flag.html. So flag.html. And then that's going to be http /1.1. And then the host is going to be anything. So again, on some servers you might get it without, but on other servers you have to put something there. So we're going to do host anything. Oh, I don't know how sensitive this is to capitalization, to be honest. So I don't know if that would have worked, but who knows. So host anything and then double enter. And then we get the actual HTML. And if we read through all of this HTML, but first we can see right here, this 200 OK response. So it said, sure, I can give this to you. And then it gave it to us. We can see this THM telnet HTTP, which looks like our flag. So we'll copy that, paste it in there. And with that, we've finished task number 4, HTTP. So now it's on to task number 5, FTP. So FTP is a little bit different than HTTP. HTTP is designed for like web browsers and stuff. FTP is specifically for file transferring. That's why it's called the File Transfer Protocol. It's like any other protocol. It has some commands here that we may need to know. So username, password, retrieve, in this case it's RETR is the command that you type, and this will download a file from the FTP server to the client, and then store, and this is used to upload a file. So if we have an FTP server, then we could reach out to it and we could transfer files to ourselves or to the FTP server, back and forth. That's what it's designed for. That's what it's supposed to do. So here they give us an FTP server. They log in with anonymous, and you don't need a password. Then they do ls, which is going to list all the available files. Then they switch to ASCII mode, and then they do get coffee.txt. And get coffee is just going to then download the coffee.txt file. So we can see them do that here. There's their name, anonymous, password. They just hit enter because there was no password. They logged in, they LS'd, then they said get coffee.txt, and then they quit. So that's what that is. They just hopped onto an FTP server and grabbed one file. And this is what it looks like in Wireshark. So this is the TCP stream of what was actually going on. Because we might type in something like ls, but on the back end, it's interpreted differently. So we can see user anonymous. And so these commands refer back to these ones, right? And we can see that because here, they didn't have to do that. But yeah, so you have user, pass, And then all of these, here come the directory listings. So list, that was, we typed in, or the person typed in ls, but really what was sent was list. And then they gave the directory listings, and then they switched to ASCII mode, and then they retrieved, or in this case, they typed in get coffee, and they got coffee. So we can see the front end, kind of what we see, how we would connect and grab something, and then we can see the traffic on the back end and how the server is actually interpreting what we're sending it. So that's pretty cool. Now it wants us to use the FTP client on the attack box at this IP address. And let's see, what does it want us to retrieve? Flag.txt. So let's do FTP. And then I'll paste that. And so I don't know if this was said. I don't think it says it anywhere. But here we go. So the FTP server listens on TCP port 21 by default, right? So here, I don't think we have to do that because we typed in FTP first. So now we need a name, anonymous, no password is needed. So now we're in FTP. So now we get ls, and then I see over here we have flag.txt. So I can just type in get flag.txt, and then it gives me command successful, transfer complete. So now I can just quit, and then I can look on my own and I can do ls, and then I see I have flag.txt. So I have flag.txt right here because I downloaded it from the FTP server. And now if I cat that out to see what it says, I can see I have this THM fast FTP. So pretty cool, right? So make sure you've read through everything, give this a try on your own, and then once you've answered the question, you can submit that. And with that, we are done with task number 5. Now it's on to task number 6, SMTP, which stands for, where does it say? Simple Mail Transfer Protocol. So this is a basic mail transfer protocol, so like sending an email, right, from a mail server to another server. And let's see. Yeah, make sure you read through this. They kind of give you an example, but I always like just jumping in and kind of doing it. It helps me understand it better. So here are some of the commands used by SMTP. So hello or EHLO, and then mail from, this says the sender, and then receipt to, this is the recipient's email, and then the data. So this is the actual message or the content that's going to be sent. And then the dot is sent on a line by itself to indicate the end. And this says the end of the, but like the end of the message. So we can see right here, they say, hello, I am using Telnet to send you an email. Then on the next line, all by itself, they send the dot, and that means, you know, that's it. We're done. So you can use Telnet to do this. Like they say, it's quite cumbersome, but it does help us better understand these instructions, and it gives us some insight. In reality, you wouldn't use Telnet because there's easier ways to do this that are, you know, automated, and you don't have to, and you can just use a graphical user interface or something. But for learning purposes, we're going to use Telnet. So here we can see they connect, they start it, they see who the mail's from, who it's to, then here's the data. So here's all the actual data that was sent, and then they quit out of SMTP. So on the back end, this looks kind of like this. We can see the hello, which is going to start it, then mail from, that tells us who it's from, who's it to, and then here's all of our data. And so we can see all of this data that was sent and then quit. So that's pretty cool. Hopefully now you're kind of getting the knack for, like, there's different protocols for different things, and those protocols have commands or rules that they follow. That's essentially what a protocol is, to communicate or achieve a task. In this case, send and receive mail. So which SMTP command indicates that the client will start the contents of the email message. So that was data, right? Because that's the actual content that we're sending. And then what does the email client send to indicate that the email message has been fully entered? That's just the period. So on a line all by itself. So now with that, we are done with task number 6, and it's on to task number 7, POP3. So now so that was sending email, right? Now we're receiving email, right? Let's say we get an email and you want to download it on your local mail client. That is what POP3 is for. So SMTP allows you to send stuff, and then you can use POP3 to receive it. So the POP3 protocol, does it tell us where it sits? It probably does at some point. At the very end, we're going to go over each of these protocols and what port they belong to. So don't worry too much about it, but I'm pretty sure it's 110 for POP3. So here's some common POP3 commands. User, pass, makes sense. Stat, which is going to ask for the number of messages. List, which is going to show you all the messages. Retrieve, delete, and quit, which all should be pretty self-explanatory. So read through those. And again, we can connect through Telnet. And okay, it is port 110. Okay, so down here we have an example of them actually doing this. They use Telnet, the IP address, and they're doing that on port 110. It's going to connect. They're going to go through it, give the user, give the password, and then they're going to ask for stat and then list, and then they list these 3 messages that we can see. So then they want to retrieve message number 3. And then we can see that message from, to, and it's the same message that we saw earlier when it was sent over SMTP. So that's how that works. And here's what's going on the back end. Again, we can see front end, what we're typing in, and back end. Sometimes they're really closely related. Sometimes there's a lot that changes. Just depends on the protocol. So yeah. You can read through all that. It's retrieving 3, it lists, it asks for how many messages there are. There's 3, that's their size, username, password, and then they quit. So very similar. Connecting to a POP3 server requires authentication. Use the following login credentials when needed. So they give us some credentials there. And then looking at the traffic exchange, what is the name of the POP3 server running on the remote server? So if we look, xclient Dovecot. I think that's how you say that. That's how I say that. So Dovecot, that's the answer. And this is just a type of POP3 server. I'm pretty sure because it's on TryHackMe, it's probably an open source POP3 server that you can use on Ubuntu. So there you go. So that's the answer to number 1. And then number 2, use Telnet to connect to this IP address. On the POP3 server, what is the flag contained in the 4th message? So we want the 4th message. So let's Telnet. We're going to paste that in. Ooh. Did I not copy this? Okay, here we go. Telnet, and then I want to paste that IP address, and then that's going to be a port on 110. Okay, ready. So the first thing that we need to do is we need to provide a username, and we do that up here using user. So let's do user, and then we'll do a space, and then give them Linda. Then we'll do pass, a space, and then we'll give them this password. So I just paste that in there, hit enter. Okay, now we're logged in. So now we should be able to list, and it's going to show us all the messages. Now I want to retrieve, it's all caps, And I think, let me double check, the retrieve command is RETR. Okay. So RETR, and then we want to retrieve number 4. So I do that, I retrieve number 4, and here we go at the very bottom. Here's our flag. So we can copy that. We can hit Control C, or nope, we're inside. So we just have to do quit. Oh, it wants us to do it in all caps. So quit, now we are no longer, connected to that through Telnet. So we quit. But we were able to get our flag, copied it, and now I can come down here, paste that in. And with that, you've finished task number 7. Now it's on to task number 8, IMAP. So basically, it explains up here that, POP3 works great if you're using one device. But if you want to check your email from different places on different computers or a smartphone or whatever, you need something that will help synchronize messages, right? So instead of deleting a message after retrieving it, you need to find something that will synchronize everything across multiple devices in your mailbox. And what does that is the Internet Message Access Protocol, or IMAP. So basically what this does, it allows you to synchronize read, moved, and deleted messages. So it keeps everything the same whether you're on this computer or if you get on a different one. And that's important. And again, just like any other protocol, we have different commands. Here's a few: login, select, fetch, which I assume fetch message number 3, header and body. So yeah, that's like get or retrieve. Then you can also move, you can copy, and you can log out. So you can do that you can get on there using Telnet. You connect to the IP address on port 143, because port 143 is the default port for IMAP. So if you do that, then you give it a login, and then once you're logged in, you can select, and then here in this example, they're going to fetch message 3, and it's going to give us the body of that message. So then we see down here, gives us all this info, and here we go. Hello, I am using Telnet to send you an email. Great. So the fetch was completed, it was able to grab everything, and then this person just logged out. And as we have been doing with this room, here it is on the back end, right? And we can see very clearly right here, the highlighting actually makes it a lot easier to read. So they logged in, they selected their inbox, they got the 3rd message body, and then they logged out. Pretty straightforward. So down to the question, what IMAP command retrieves the 4th email address? So we can just do fetch, and then that would be 4. And then I assume they want the body of the message. Not Bobby, body of the message. So I think that's how that would be. Very good. And if you didn't know that they wanted the body and you just type in fetch 4, the hint lets you know we want to download the body. So should be pretty straightforward. And once you've read through everything, answered that, you're done with task 8. Now it's on to task 9, the conclusion. So we just have gone over a bunch of these protocols. It's important to know the ports for these protocols. And in some cases, it's important to know the transport protocol. Most of them use TCP, but DNS uses UDP or TCP. That's important to know. And these are the default ports. If you're going to take any sort of test, CISA Plus, Pentest Plus, any of those things, you're going to have these memorized, because they will ask you questions assuming that you know your port numbers. And again, there's 65,000 ports. Not all of them are used commonly. So there's probably only 30 that you should know off the top of your head. I mean, if you're really into tech, there's some guys that know way more than that off the top of their head. But to pass your generic tests for cybersecurity or whatever, or like your Network Plus, CISA Plus, A Plus. There's just a handful of generic ones that you need to know, and these are some of them. So you got to know these. Make sure you go through, read them, try and memorize them. And with that, we have finished task number 9, so read through that, mark that. I hope you guys found the video helpful. If you did, give it a like and subscribe. That helps me out a lot. And with that, we have finished the networking core protocols room from TryHackMe.